So once we are here onto the source control menu, we can see there are two options, right? The first one is supposed to create a repository locally on your computer. And the second one will create a repository which will be, it'll first of all, it'll need internet connection, right? And it'll create a repository in your GitHub account. All right, you can see it says published to GitHub. Now, why does VS Code provides GitHub, built in? Why is it that? Because first of all, you should know that GitHub, VS Code, both of these are actually owned by Microsoft. All right. So even though these both are like open source tools, these are owned and maintained by Microsoft. So that's why they are like, automatically connected with each other. And if you need more control, you can go to extension, okay, and search for GitHub, and you should get this extension, GitHub pull request and issues. You can see that it's made by GitHub here, right? So it's official extension, and it is used for few extra activities like creating a pull request or looking at your issues, solving issues, stuff like that. So once you are in, if you have installed this extension, first of all, this is optional. This is not something necessary, but you can install it for better control. And once you have installed it, you will have this icon here, which basically means that you have installed it. So let's come back to our source control. Once you are here, you can do two things. First, you can initialize everything in your local computer, which I'm going to do. All right. So I have this folder. I'll initialize, right? And it's done. So once I clicked on initialize, it's done. So what I did is I use the GUI of VS Code to initialize the repository here. Always remember that I'm inside the try folder. All right. So when I did this, something called as wait. So see, I'm inside the try folder, right? In my file explorer, you can see that after I initialize Git, something called as .git is created here, right? .git is created here. This folder is actually what contains all the system information for Git and like how everything is managed. The changes are stored in there. So if you have created something inside a folder, that whole folder becomes a repository. All right. So now try has become a repository in itself. Whatever changes I'll make inside of try will be actually synced and like maintained and looked upon by my Git. So remember that till now I'm only working in my local computer. It has nothing to do with the internet yet. All right. So uh, let's come back to our source control. You can see changes, right? So it says changes, and it says that the change was made in main. Of course, we have only single file, which is named main.py. And there are a few options. First of all is open file. Okay. Second option is discard changes. Third option is stage changes. And then this U basically means that it was the one which is like added, right? So we'll click on open file. We'll see what happens. Since this file is already opened here, so it won't do anything, of course. But once we click on discard changes, the changes which was made will basically be undone. So if I click on this file will be deleted because the change was that I had created this file. So we don't want to delete it. We want to stage it. So what is staging? I stage it. See, stage changes. You can see that it's in the stage changes column now. So, and we don't have any new changes anymore. So what is staging? Staging basically means that you have the second stage of decision where you have, let's say if you have changed like few small things, like you have fixed some spelling mistakes and stuff like that in your code, but you don't want to commit it as a feature, let's say. So you can stage the changes so that even if you close the file or like your system turns off, the change will be tracked by Git, but it is not yet committed. So that change is not something big in itself, but it is keep tracked of. So you won't lose the change, all right? But it is not committed yet. Let's say I want to commit it, right? It's a big change because I have added a new file. So it's a big change. So I'll write, let's say, first commit. So what I'm doing here is I'm writing a commit message. Commit message, which first of all, make sure you write meaningful commit messages. this folder is not really that important, so I won't really go in deep. But when you write commit messages, make sure you write meaningful in a sense. When you actually want to revert some change, right, undo some change, so these messages will help you. You will know which change was what, right? So let's say if you added a function called as get day function or something, so you can write the commit message added get day function. And after adding this function, your code is working fine in your computer, but it is not working fine in others' computer. It means that this working function, this get day function basically broke your code, right? So you want to remove it. So you can go to the code, delete everything and create new state changes, stuff like that. Or you can come here, you can search for added get day function, click on it and undo. It's easier, it's safer, because if you delete the function and change something else, it might again break something other, right? Further, which is, you'll realize when you're making actually bigger projects, right? You'll realize this, that once you start changing stuff, something which you think will not affect your code will affect your code, and it is like kind of frustrating. So that's why it is really helpful. So once you have written your commit messages, there's a tick option which basically means commit. Okay, this option. So I'll click on it and wait, and now it is committed. Okay. So what we have done is we have initialized the repository offline locally on our computer. Okay. We have made a change, we have staged it, and we have committed it. Let's see how we can, push it to GitHub. So first of all, when you are here, if you're doing this for the first time, so you can see here there will be a there will be an icon which says Git published to GitHub, right? A cloud with an up arrow. So this is where it is, right? Once you click on it, let's see. You can see here that I like directly get the option to publish to GitHub private repository or public repository. So I have GitHub Pro, and like yeah, I think you all know that you can get GitHub Pro like from Hack Club for free, right? I don't think you have seen it, but I had sent in the like very first. I think I had sent it a year ago or so that you can get GitHub Pro for free from Hack Club. So if you have GitHub Pro, you can publish it to a private repository, which no one else will be able to see. But you can also publish it as a public repository, right? But if you're doing it for the first time, you will get an option to sign in first. Okay, it will ask you to sign in. Once you have, let's show you how it's done. First of all, so I won't do this yet. What I'll do is I'll sign out of my GitHub. We have signed out, and then I'll click on it. We are still getting. So yeah, once you click on sign in, you will be taken to your browser. You'll have to authorize GitHub. You'll have to enter your ID and password, and then you'll be signed in. All right. The process can be different. Now, I want all of you to perform all these steps and let me know if you've like encountered any problem till here, like till signing in. One of the reasons I like invited this meet was because I wanted to see if there like if the steps have changed a bit or like people encountering problems something, because it has been a long time since I did this. So I don't remember exactly what are the actual steps involved. Is anyone actually following along? So, okay. So one more step. All right, we'll take one more step. The next step, I'll just do this step. All right, I'll publish to GitHub. So click on it. We will have the option of private repository and public repository. I'll of course use public repository. See, unless you have something really like private type of project, always use public repositories. It's always good to use public repository. So once I click on public repository, you can see here that it's done, right? And so the icon where you had a cloud with an up arrow has actually become some kind of a circle. It is basically a sync symbol, right? The symbol is always used for sync. So whenever you have to sync something, see, it says synchronize changes, right? So now you can use this to synchronize changes from the cloud. All right. So let's create a program now. Oh, by the way, if you have completed it and are like sitting idle, I'll show you something really interesting. So I have this piece of software from GitHub where GitHub made this new AI powered autocomplete feature. It's called GitHub Copilot, and it's like really interesting. All right. So I'll write a comment. Okay. Let's see. Write a Python program to add two numbers. All right. I wrote this comment. Now you can see the autocomplete thing, right? I think you can see here autocomplete thing. You see, like Python, this GitHub Copilot actually suggests me the whole code which I have to take. Now observe something. I'll just press tab. All right, it's auto-completed. I'll press enter, and it is suggesting me the next line by itself. I'm not even typing anything. Okay, I'll just press tab. Second line, right? I'll wait. Um, I think the internet is not really fast enough. Let's see. So you can see that like it suggested me the most of the part is suggested by itself, right? GitHub Copilot, but it might be like okay, it's some kind of autocomplete. I'll do something else now. I'll create a new file. Okay, this time around a C file. I'll name it main and let's say uh, list dot c. Right? I'll create a list dot c. Enter. I have a C file. I'll write a comment. Uh, let's just think of a complex program, right? So not really complex, something. Let's see, we program to create the linked list. All right, we program to create a linked list. So I'll start include and then int main and now you will see that I don't have to write anything at all. Okay, it's everything like I am just pressing tab and enter. That's it. And GitHub Copilot is taking care of just about everything. You know, you can keep on pressing tab and enter for it to keep on working. See? So like, look at this. It wrote this complex program by itself. GitHub Copilot. Also, it's not like limited to this program. GitHub Copilot works really well with C. The reason for it is because in C, to achieve some task, there are actually limited ways. So in Python, right here, if I wanted to add two numbers, there can be like different multiple ways to do it, right? I can take A, B, then A plus B, save it in C, then print C, or I can just print like this. Okay, that's why it waits for user input. But in C, to achieve something, there are like limited number of ways. So that's why GitHub Copilot will work like really well in C. So I have like tried to write really complex programs with GitHub Copilot, and it will like write whole program by itself, and it works. It's not actually like only writing; it will actually work really well. So this is something I wanted to demonstrate. It is still in preview build, so it is going to develop even further, and it's AI. So think about it. So the programs which we have to learn in our engineering, right? Data structures and algorithms, right? We had to learn all of this. We had to like work so hard to learn this and then understand this, practice this, and now GitHub Copilot that can just do this. So why do you think companies will lead us? They can just use this program to write it, and it's free, right? GitHub Copilot is free, completely free by till now. So it's always good to scale ourselves up. So I think, are you, is everyone done with, logging in and publishing your repository to GitHub? Is everyone done? Is anyone facing any kind of problem? I have no idea how many of you are following along. Okay, so we'll use this method. If you are done, okay, yeah, react with a thumbs up. Okay, I see Samarth already did that. He predicted autocomplete, GitHub Copilot. Okay, Nishant is done. Meryl is done. Only 3 people. Harsh, are you done? Harsh?
Yeah, I am done.
Me. All right. So see, I have now 2 more changes, right? So I can just stage all of these changes, or let's see, this time around I'll use terminal. All right, I'll use terminal because why not, right? So I'm inside. Let's see, git your branch is up to date with origin main. Changes not staged. So the message which you get here, let's see, on branch main, first of all, on branch main. So we have only a single branch here, that is main branch. You can see here branch name, right? Main branch. And it says your branch is up to date with origin main. When it says origin main, so basically it means that the syncing between cloud and the local files, the local repository. That's what it means. Now next we'll move on. It says changes not staged for commit. So we can see that we have 2 changes which we have not yet staged, right? It says changes not staged for commit, modified main.py. All right. So this is modified main.py, but it is tracked. So basically, Git knows that this file exists. Git already knows because we have staged it once, right? So Git knows that main.py exists, but it has been changed, which Git has no idea about. So it is telling me to use git add and file name to update. Okay, so this will be committed, and use git restore file to discard changes. So if I don't want these changes to stage, I don't want these changes to stage, I have changed my mind. So I'm going to use git restore. See, you can see everything is told by git, right? It is already instructed here. So, but below it is something interesting. It says untracked files, right? List.c. So the list.c which I created right now is actually untracked. Git doesn't know about it. I created it right now, but I have not staged it even once. So Git can see it because it's inside try, right? So Git can see that something is inside try, but Git doesn't know what it is. So it is untracked, right? It is not being tracked by it. So what I need to do is, let's see, I want to what you can do is, let's see, git add. Okay, now I can specify the file name. So I can say main.py. Also remember, you can write main.py because main has no space in its name. If your file have space in its name, always use double quotes. Okay, write inside double quotes. So main.py. If you have space in the file name, if you don't have space, you will just write like main.py. Okay. Now what I can do is I can do git add main.py. Again, I can do git add list.c, or I can do git dot. So what dot will do is it will stage all the changes. Now you can see here in stage changes, both the files have shifted from changes to stage changes. It means now let's see what is the difference we made, right? So let get status. Okay, so now what it says on branch main, because we have a single branch, your branch is up to date with origin main. Okay, changes to be committed. Okay, so it says changes to be committed. So we have no unstaged or untracked changes. Last time we had one change which was unstaged and another change which was untracked, right? This time around, both the changes have been staged but not committed yet. Use git restore staged file to unstaged. So if I change my mind, I don't want, let's say, main. So what I can do is get, okay, restore stage and then main.py. If I do this, let's see what happens. So you can see that again the main.py shifted from state changes to changes, right? So if I commit now, only list.c will be committed, but main.py will not be committed. But I don't want that. I want both the changes to be, committed. So let's add back, add dot will basically stage everything. All right. Now git commit, git commit. So we all know what commit does. Commit basically saves the changes. Now what commit will do is commit will create a snapshot, kind of a snapshot, so that whenever you want to restore back to a point, you will restore back to your previous commit. Always, whenever you undo something, you will come back to your previous commit. All right, so that's what commit does. So git commit, but always remember that we have to write a message, right? How can I write the message in the command prompt or the terminal, right? I'll use M is for message, and the message can be, let's see, added to file. Now you can add a description as well. So you have added a message. You can add a second slash n, right? Sorry, dash m, which will add a description. So whatever you enter here will be long, description of the change which you made. So I can just write it added to files. No, added one file. Sorry, I added one file list.c and updated main.py. So this can be the description. Enter. Added two files change. See, commit has been done. All right. Now what you can see here, let's come back to this part. You can see the up arrow has 1 written in it, right? But the down arrow has 0, which means that you have one change in your local repository on your computer, which is not present in the cloud. So GitHub did not see this new commit yet. This commit which we made right now here, right? The commit which we made here has not yet been seen by GitHub. Our Git in our local system has seen it, but GitHub did not see it yet. That's why it says one up arrow, which means one upload. So we have one commit which we can push, right? So you can always click on the sync button and it will automatically sync it. Let's try to use command, right? So the command to push is, let's try to write git push. Let's see what happens, right? Okay, so you can see that after I wrote git push, because I have already specified the remote, it is called remote, the GitHub, right? So it is already automatically synced with it. You can see that the arrow disappeared, which means now our files in our local repository and the files in GitHub are in sync. So to understand if it's actually working like intended, I'll open my, oh my God. So I'll open my GitHub. Okay, let's see. So this is my GitHub account, right? I should have a brand new repository. Come. Yep. So created 4 repositories. Let's see. The latest one will be at the top, right? So the latest one was this one. And you can see it says updated 1 minute ago. So basically the commit was like recent, right? I'll click on it. Click on the repository. Let's see what happens. So we have 2 files, this.c and main.py. Okay, we had. Now look here, right? We have 2 commits. Click on it. We'll see what are the 2 commits. So we remember when we made the first commit, right? We wrote a message. The message was first commit. Look at the message. It says first commit. And for the second one, but for the first commit, we didn't actually write a description. We just wrote a message, but no description at all, right? For the second one, we had given the message as added 2 files and we had wrote a description, right? See, after I click on this, you can see the description. Added 1 file, list.c, and update. Oh, spelling mistake. Updated main.py, right? Also, this side, you can see that there is some kind of, tag. So this is how GitHub tracks your changes. This unique ID will be assigned to every commit you make. All right. And whenever you work with commits, right? So this is how GitHub will track your history. So if you want to revert back to a commit, you can just come here and revert back to this commit. You can just click on this, right? So I clicked on it. You'll see this is everything concerned with this. I'll go back, then I'll go to this one where it says what changed. So this whole file was added, and here this line is red, which means it was removed from the file, and all the green ones were added. So our first commit was only print hello world, but in the second commit, we removed hello world, right? And we added this whole thing. So now we have an idea about that everything is working fine, everything is syncing, right? We know that it's working fine. So I'll go back to my VS Code. There it is. And so till now we have seen this, right? So what we did is we created a folder. Okay. Always remember to start working with command prompt. All right. Always start working with command prompt because it keeps things clean. Also, one mistake which I have seen few people make recently is that they'll initialize repository in their parent directory, which you don't want to do. It can become really messy. So let's see. I'll go to my file explorer. I'll go to DC. Okay. So typically I keep all of my programming stuff in drive D. All right. I'll open drive D. In drive D, you can see books, data sets, right? Embedded games, ID. You can see so many different. Oh yeah, you can see so many different folders, right? So I keep all of my stuff in programming, right? I'll open programming. In here, there is C codes, ESP, learning Java, machine learning, project 0, project 1, stuff like that, right? So in project 1, I have 2 projects currently going on. So what you can mistakenly do is you can initialize a repository here inside documents, or you can mistakenly initialize a repository inside programming, or you can initialize a repository inside, let's say, MLL. Okay, MLL is actually let's say project 1, but I have 2 different projects here, which can become disastrous. So always remember to start working with command prompt, because then you can properly navigate and you will know where you are doing what you are doing, right? So here I have actually initialized 2 repositories. So inside advertise C, you can see .git file, which means one repository here, and inside here another repository here, right? So if I had initialized the repository in the parent folder, let's say here, it would cause different kind of unseen problems, which would become really messy. It would cause me headache. So I don't want to do that. Always remember that you're also keep an eye out for this name, right? So where you are working. So if the name is try, it means the repository will be initialized in try. So here what we did is we created a folder in command prompt. We opened the folder, okay. Then we opened VS Code inside the folder, and then we created files. We initialize the repository from here in our local computer, not in the cloud, on our local computer. All right. And then from our local computer, we initialize the repositories, state changes, made a commit, and then we published it to remote. The remote was GitHub in this case. It can be different depending on the situation. Like there are other providers like Bitbucket and stuff like that, but like GitHub is the most popular one and really widely used. So I don't think you'll encounter anything other than GitHub. So we published the changes to GitHub, and we saw how the commands are like actually scaled to the GUI. So we could do it using GUI and the command. But here when we wrote the message, we clicked on the tick icon, right, which was commit. We can see there are few other icons here. Let's explore. Right. So then immediate next one is called create pull request. Now this is interesting. What is a pull request? Right? So this whole folder is something which I am doing right now, right? Like it is my folder. I started it, I created it, and I'm working on it. So it is fine because I can just make a commit. But what if this is my folder? Let's say the team which is developing the website right now, our club website, they are working in team, right? So two, three people are working together, but they are working in their like separate code, right? So how will they sync the code with each other? How will they do that? So they have one single repository. Anyone can have the repository, and the other person actually forks it, right? And first of all, there are different ways to do it. You can add a contributor. If I'm a contributor to a repository, I can directly contribute to it. But if I'm not a contributor and I have seen an issue which I want to solve, I can just create a pull request. Okay. So what I so now I'll show you how to clone a repository. All right. How to clone a repository from GitHub. Right. So I'll close this file because we don't need it anymore, and I'll create a new one. So cd mkdir er. My naming sense is really bad, so I'm sorry. That's how it is. So I created. Always remember that I went back. See here, I went back to the parent directory, right? And again, I changed the directory to desktop. Again, I created mkdir creates new folders. So I created tr2. You can see it here, right? Tr2, and then I changed directory into tr2. So I'm inside tr2, and inside tr2, I'm starting Visual Studio Code. All right, let's see. So I started VS Code inside tr2 now. Wait. um, yeah, I'm sharing screen now. Okay, yeah. So I want to clone something from somebody's. GitHub. So I have to first of all figure out what do I want to clone. I'll I'll see what can I clone. Okay. Okay, so all right. I found what I wanted to clone. Okay. Share my screen. Okay, so the this is Nishant's GitHub profile. So he's the one who is developing our college website along with Summer, I think. These two are currently the only one who are working on the website. This is the repository which contains some of the primitive code of the new club website. All right. So I'll try to clone it. So how to clone it? So I'm here. I'm here inside the repository, right? So here you can see under code. So I'll click on it, and there's this option to clone, right? And there's this help menu, which tells us which remote URL should I use, right? It will help. But let's see, there's this HTTPS. I'll copy this because HTTPS is generally the normal one, right? Hypertext transfer protocol. So I'll just use this, copy the link, all right, and go back to our trustworthy, and I'll write the command get clone. Now you can use recursive. Recursive basically means every time you know it will be recursive, like it will repeatedly clone it. So if some updates are made in the remote, it will be synced. I don't want to do it. I'll just paste it. So control V and enter. Let's see what happens. Cloning it to Hack Club, and it's done. See, so what happened is I did it inside tier 2, right? So you can see that a new repository has been created, which is Hack Club. Now, why is it named Hack Club? So here the repository is named Hack Club. See? Repository is named Hack Club. That's why again it's named Hack Club here. So I'll see gallery. All right, index.html. I'll click on index.html. I don't really want to break anything because I'm here a group of students and develop. Okay, so what I'll do is I'll remove this full stop. I'll put a comma here. All right. And this way I changed something, but I didn't really make a significant change, right? Now I can stage it. Now what I'll do is I'll create a pull request. Let's see if it works. So merge changes. Um, okay, so I think it will be better to first create a different branch for it. New branch. Okay. So here it says from patch 1 to master updated main section. I'll try to keep this. Okay, yeah. So there's no, this branch is not yet published, right? So I'll just publish. There are no commits between master and main. Okay, I think I forgot to commit the changes, right? Did I? I did. All right. Uh, go back to place, refresh it. Okay. So you can see we have a new pull request here, right? Pull request. It says a new pull request has been made. I'll click on it, and it says updated min section. That was the pull request message by default. I didn't actually change it because it was not a big deal. I click on it to view, and the message says change full stop to comma, right? And the commit is actually this. This was the commit message which I wrote, right? This is the commit. So this is not a significant change, right? And because I think I am a contributor to this folder, that's why I am like able to merge it. But generally, the only person who has created the repository is able to merge it, right? So here, because me, Samar, and Nishant, all three are contributors, so all three of us or any three of us can merge it. All right, and there are different options to it as well. So create a merge commit, squash and merge kind of force merge, right? So you can actually not merge at all. You can actually reject it, close pull request, write a message what was wrong with it. So if the pull request is not valid, let's say somebody tried to randomly create some kind of pull request which is not relevant or something, so I'll just write a message that yeah, this uh, this is not really relevant, right? And then I'll just close it, right? But this is not a big change, so let's come merge pull request. We'll see what happens, right? Yeah, this is what I want to do. So pull request was merged successfully. Uh, Go back to Hack Club. Now you can see that the pull request notification has disappeared, right? Now it has disappeared, and the latest commit here says Gautam Flash. That is my ID. Merge pull request number one. So this was the first pull request ever created from Nishant and patch one. So from this, I have merged one pull request, right? That's what it says. Click on the description. The description says merge pull request one from Nishant patch. That is all. And the pull request message which shows up here, right? So let's, lot of things happened, right? Let's look at what we went through one by one. So first of all, we cloned something. So to clone, I just used git clone and the link which we found in the repository to clone it here. All right. Always remember that when you clone it, the whole folder will be cloned. All right. Whole folder will be completely copied to your folder inside of your folder which you're working in. Okay. So after cloning it, I changed something. Okay. I changed something. So I don't want it to be directly implemented. So what I did, I changed the branch. I created a new branch. See, the branch says patch one. So this is a different branch. The main branch is called master, or sometimes it's called head, sometimes it's called main, anything you can choose. But this is the general syntax. So here you can see origin, right? Whenever it's written origin basically means it's a remote branch, right? Remote in the sense it's on the internet, so it's on GitHub. And whenever the name is without origin, like this patch one, this is without origin, right? Master without origin. So these two are the local branches in my system. And this master and origin patch one, these two are the repositories which are in like GitHub, right? Online. So when you make a change, let's see, I am inside here. Okay. So I'm inside this, right? So what I'll do is, so there's this line, right, which is like which ended abruptly. So let's try. I'll try to add something else. Uh, okay, GitHub Copilot is suggesting something. Let's try to go with it. It says, okay. Wow, did you just see, like, GitHub Copilot just suggested me this whole line. We are a group of students who are passionate to learn and develop. Like, it's actually mesmerizing how this technology works. But like, okay, so this one line was added again, right? In patch one, always remember it is working in patch one. And the star means something has been changed. I'll come again, follow the same process, right? And let's see, added a line to paragraph. Create this. So, a grateful request. Okay, I did not push it. Oh yeah. So we created our second pull request, right? So here's the second pull. Now what we'll do is, last time I went to GitHub, github.com, right, and merged the pull request from there. This time around, I'll try to do it from here. So this is where this thing comes really handy. Okay, description. So it says everything. What happened? This branch has no conflicts. So I can choose to merge the pull request, but what I'll do is I'll not merge it. All right, I'll just say this is mm, uh, needed. Wait, that's what I want to like really. And then comment. This is not really needed for us. Was the request. So I have just closed the pull request. So I created one, right? The pull request was called pull request number 2. You can see here. And then I closed it as well, right? Now let's switch back to github.com to check the changes which we made. Refresh. And we'll go to pull request. We see that there are no new pull requests and there are no new commits. So basically, which means that because we rejected it, it won't show up because we actually rejected it, right? So now what we'll do is now, yeah, now on the branch. So here we have two branches now for this repository, right? We have batch one, and then we have master. So master is the main working branch, and usually for bigger projects, whenever you change something big, it's suggested to not do it in the master branch because you don't want to do big like make big changes in master branch. And when you want to change something, just create a new branch, all right, and see if they have any conflicts. So if they have like no conflicts, you can always merge it. So here, code issues, there are no issues. Pull request, no pull requests. So forget all this stuff. Now come to master, and then it says two branches, right? I'll click on it. Let's see. So it says default branch is master. Your branches, which you have created, is patch one. Now we see that in master there is no activity, right? But in patch one, there's some kind of activity. Let's see, closed. And number two, we know what it is, right? It is the second pull request which we closed just now. So I'll click on it. Let's see. So we are here. There are no any open pull requests, which means we had closed, right? So it says two closed pull requests. We'll click on it. So see here, one is blue, okay, and the symbol basically looks like a triangle, right? So you can see that it is a merge symbol, which means we merged two branches, right? there was the master branch, there was the patch one branch, and there was a pull request created, basically, which meant please merge it, and I allowed it, so it is merged into single one. The next one was, however, there were two branches. I asked please merge it, but then I did not allow it, right? So it was rejected. That's why it's in red color. That's all there is to it. And like by far, whatever you have seen, right? This is like most of it which you are going to need for a like long time. After you have, you know, taken up some really advanced projects, then you are going to look at what are actions, what are like how to manage projects, what is a big wiki is not really something interesting, but like let's see security or insights. Let's click on insights. Let's see something. So insights is basically your whole repositories. How do I say it? It's the biodata. Like it will tell you everything. So how many pull requests were merged, how many are open, how many were closed, how many. Okay, interestingly, you can see that it says zero closed issues, right? So what does this mean? So there is this issues tab. Here you can actually create one issue. Let's see if this is a project which is working, right? Which is deployed, which is actually available to customers or something, right? And it has some kind of problem. So the previous Hack Club website has this problem where it was not responsive. So it was really good on PC, but once you open it on phone, it was cursed. It was like really bad. All right, not tolerable. So you can what you can do is you can open an issue. You can say like, see, this project has this issue. Please solve it. So the person who is maintaining the project will look at it. Okay, they'll look at it and then they'll solve it if they can. If the issue is like not relevant, they'll just close it. Like same like pull request. But pull request is basically you suggesting the change. You have actually written the code and you are telling them this is the solution. Please apply this. Issue is basically you are just telling the problem. You're not telling the solution. That's it. Now come here. One of the important parts is what does this mean? And it says one, right? I'll just click on it. So you can see that my repository shows up here, right? If you remember correctly, like, sorry. So what this means is there's an existing project which you would actively like to change. What I mean by actively like to change is I cloned the repository to my local like my local system right here. I have cloned it. But if something is changed by Nishant or Samarth or something in the remote directly, it won't reflect here. I will see the sync button, right? It will tell me that yeah, one change is available to download, but it will not automatically sync. What fork will do is I can actually completely try to change this files for myself. So when I fork a repository, because I'm the contributor to this won't really show up here. I will try to do it with a different one. Let's see. I'll do it. What's profile? Hopefully he has something which I can. ML, yeah, ML is interesting. If it is bad, I'm going to roast it. So yeah, see, so this dude has some kind of project here, right? Bag of words, spam classifier.py, readme.md, mail.csv. So let's see, I'm going to the project and I want to change something. Okay, I don't really like the readme.md. It looks like it's like some kind of worked it in a haste. So I'll click on it, okay, and the file opens. So this edit button. What will happen if I click on this, right? I'll click on it. Now what I did is you are making changes in a project you don't have write access to. We have created a fork, all right, of this project for you to commit your proposed changes to. Submitted a change will write it to a new branch in your fork so you can send a pull request. All right. So if I want to create some change here, right now, let's see. Uh, what do I want to change? Let's see. I want to tell. Uh, preview. I'll look at the preview once. Okay. Oh, I changed something, right? So let's see. So updated readme.md, added how to install the Streamlit library, right? And propose changes. Let's see what happens. Now I have changed something. Now I can leave it just here, right? I can just leave it here. I changed something, but I have this option to create pull request. So the whole concept of forking is that you are changing something actively, okay, and then you want to suggest these changes to the author, right? So now I'll create pull request, and allow edits by maintainer, of course. Maintenance can edit it. Create pull request. So looking for ability to merge, so it has no conflict, so it can be merged. Sometimes there are conflicts between repositories, all right, like your pull request and the repository, and you'll have to manually sort out the conflicts. So I'll ask maybe Samarth to allow, like, merge this pull request. Can you do it, Samarth, please? I'll go back to my profile just for the essence of profile. So look, you can see that like to simply create like unordered list or a bulleted list, you can just use both. Okay, yeah, you can just use a dash, right? So you saw how I did this, right? So I'll commit this new file first of all. And now what I want is I want all of you to go to this list.md. All right, forget, you have to forget to edit it and add your name below my name. All right, all of you have to do it right now. You can either create a pull request if you want to, like you have to write. If you forget, you have to create a pull request to add it, and we'll review it and we'll like merge it. So be on it, okay? Try to do it as quick as possible. Meanwhile, I'll check if Samarth has merged my pull request. Yeah, see, updated in.md, it has been merged. Pull request successfully merged and closed. So it has been merged. All right. Let me go back. If you create this pull request, like this pull request, right? That means okay, Nishan then is already done. Nice. You have to come to this list.md file and add your name below the list of the names. So we three people are the contributors. All right. So for us, like please give me a reaction if you are working on it, because I don't know if somebody is doing or like people have actually left the meeting. I don't really know.